In our next module, today we are going to start class 9th physics chapter 1 motion. The motion is the first chapter which having the basic concepts of physics which you have to learn in class 9th. This chapter basically deals with the motion in the straight line, the motion in the circular path, the non-uniform motion, types of motions and all the quantities, units and the three fundamental derivations of units, how you have to derive that. In our next module, we are going to start the next chapter, that is chapter number 8 of physics. The chapter name is motion. Here in this topic, we are going to give you a brief knowledge of the chapter, that is motion. What is the describing motion, motion along a straight line, what are the different types of motion, that is uniform motion and non-uniform motion, what is acceleration, what is average speed, what is average velocity, the different graphical equations which will be used here in this chapter, and also we are going to introduce a brief note on the circular motion. These are the main topics which we are going to learn or visualize in our this module. So try to learn it, as we are talking to our many colleagues and teachers that how to explain this chapter clearly. The teachers have told the following methods, so please take full attention in this chapter, and because this is the basic chapter, if you don't get this, the whole physics will be unknown to you. So please understand this chapter clearly. Introduction. In our daily life, we see some object at rest and other in motion. Birds fly, fishes swim, blood flows through the veins and arteries, and the car moves. These are some examples of the state of motion. Motion is the state of body if it is positions changes with respect to time. There are situations where the motion is inferred through indirect evidences. This means that if we are taking a tree as a origin, then from the respect to tree we are moving a distance. This means the inferred through indirect evidences. An object may appear to moving one person and stationary from other person. In this chapter, through the lecture and the slide, we are going to study motion in a straight line, and at last we shall discuss the circular motion. The last second point means that if we are looking inside a train, the train used to move in the clearance of our wave. The train used to move, but the persons who are sitting inside the train, they are used to sit quietly. They do not used to move, but the train used to move, and they move with the train. So the peoples were not moving inside the train, but the train is moving. This means that an object may appear to moving for the one person and stationary for the some other person. Physical quantity. Physical quantity is divided into two quantity: scalar quantity and vector quantity. Scalar quantity. The quantity having one magnitude, it is said to be scalar quantity, that is mass, distance, speed, time, temperature, boiling point, density, work, energy, etc. Vector quantity. The quantity having both magnitude as well as the direction, it is said to be vector quantity, that is displacement, velocity, acceleration, force, momentum, torque, etc. To describe the position of an object, we need to specify reference point called the origin. As per the NCERT, you can see in the NCERT textbook for the more reference. Motion along a straight line. The simplest type of motion is the motion along a straight line. For example, if an object starts its journey, it travels from O to C, then C to B, then B to A. As per the given figure, you can see here. The total path covered by an object is called the total distance covered. The shortest distance between any two positions is the displacement. Then in the next slide, we will go through the difference between total distance covered and displacement. Differences between total distance and displacement. Total distance covered. Total distance covered means total distance. The value of distance covered is only positive. It cannot be zero. It is a scalar quantity. Displacement. Displacement means the shortest distance between any two points. The value of displacement may be positive or negative. It can be zero. It is a vector quantity. It can be asked in the examination because this question is very important in the form of examination point of view. Differences between uniform motion and non-uniform motion. Uniform motion. If the object covers equal distance in equal interval of time, it is said to be uniform motion. For example, if an object covers 50 km in first hour and another 50 km in a next hour, then it is a uniform motion. non-uniform motion. If an object covers unequal distance in equal interval of time, it is said to be non-uniform motion. For example, if object covers 50 km in first hour and again 30 km in next hour, then it is said to be non-uniform motion. Measuring the rate of motion. The ways of measuring the rate of motion of an object is find out the distance traveled by an object in a time. This quantity is referred as speed. The SI unit of speed is meter per second. This is represented by the symbol m/second. The other unit of r, centimeter per second, kilometer per hour. To specify the speed of an object, we require only its magnitude. The speed of object need not to be constant. In the most cases, object will be in non-uniform motion. Therefore, we describe the rate of motion of such objects in the term of average speed. The average speed of an object is obtained by dividing the total distance traveled by total time taken. That is, average speed is equal to total distance traveled upon total time taken. If object covers a distance of years in time t, then its speed will be v is equal to s by t. Here s represents the total distance covered, t represents the time, and v represents the speed. Speed with direction. The rate of motion of an object can be more comprehensive if we specify its direction of motion along with the speed. The quantity that specifies both this aspect is called velocity. Velocity is the speed of an object moving in a definite direction. The velocity of an object can be uniform or variable. It can be changed by changing the object's speed, direction of the motion, or the both. When an object is moving in a straight line at the variable speed, we can express the magnitude of the rate of the motion in the terms of average velocity. It is calculated in the same way as the way calculate the average speed. And in the case of the velocity of the object is changing of the uniform rate, the average speed is given by the arithmetic mean of initial velocity of the final velocity of the given period of that time. Average velocity is equal to initial velocity plus final velocity upon 2. Mathematically, VAV is equal to U plus V upon 2, where VAV is the average velocity, U is the initial velocity, V is the final velocity of the object. Speed and velocity have the same unit, that is meter per second or m/second. Rate of change of velocity. During uniform motion of an object along a straight line, the velocity remains constant with the time. In this case, the change in the velocity of an object for any time interval is 0. Second point, in the non-uniform motion, velocity varies with the time. It has different values at different instant and different points of the path. Thus, the change in velocity of an object during any time interval is not 0. At this time, we introduce the new physical quantity, that is acceleration. Acceleration is the measure of the changes in the velocity of an object per unit time. That is, acceleration equal to change in velocity upon time taken. If the velocity of an object changes from initial velocity u to final velocity v in time t, the acceleration a is equal to v minus u upon t. This kind of motion is known as accelerated motion. The accelerated is taken to be positive if it is in the direction of velocity and negative when it is opposite to the direction of velocity. The SI unit of acceleration is meter per second square. If an object travels in a straight line and its velocity increases or decreases by equal amount in equal interval of time, then the acceleration of the body is said to be uniform. The motion of the freely falling object in the example of uniformly accelerated motion. On the other hand, an object can be traveled with a non-uniform acceleration if its velocity changes at the non-uniform rate. For the velocity, it has the car traveling along the straight road increases its speed by the unequal amounts in unequal interval of time. The car is said to be moving with a non-uniform acceleration. Graphical representation of motion. Distance time graph. The change in the position of an object with time can be represented on the distance time graph adopting a convenient scale of choice. In this given graph, time is taken along the x-axis and the distance taken along the y-axis. Distance time graph can be employed under the various conditions object move with the small speeds, non-uniform speeds, remain at the rest, etc. This is the graph showing the non-uniform speed from the distance time graph for a car moving with non-uniform speed. Graphical representation of motion. Second part. Velocity time graph. The variation in velocity with time for an object moving in the straight line can be represented by the velocity time graph. In this graph, time is represented along the x-axis and the velocity is represented along the y-axis. If the object moves at a uniform velocity, the height of its velocity time graph will not change with time. It will be straight line parallel to x-axis as shown in figure 8.5. Here the figure 8.5 represents velocity time graph for uniform motion of a car. Yes, you can see that AB parallels CD. Here is a graph which depicts velocity time graph for a car moving with a uniform acceleration. This means a uniform acceleration can also have a straight line on the graph which is not tended toward the parallel, but it is a vertical line to the time axis, that is cutting at origin So we get this type of graph in the case of uniform accelerated motion. In the previous slide, we have given you a equation from NCERT to take out the area covered by an object. Here is the graph that shows the velocity time graph of an object non-uniformly accelerated motion. Now we are going to learn about equation of motion by a graphical method. Please refer to NCERT while reading the lecture. Here the following lecture I have usually taken the NCERT book. I will teach only the main points in that. Here the three equations of motions are v is equal to u plus at, s is equal to ut plus half at square, 2as is equal to v square minus u square. Here you can basically in equation 8.7 you can also represent it as v square is equal to u square plus 2as. Okay, and for other references please refer to NCERT. By the help of following graph we can take out all the three equations which are used in the equations of motion. I am telling you again to refer to NCERT while studying the lecture. Let us draw AD parallel to OC. From the graph we observe that BC is equal to BD plus DC is equal to BD plus OA. Substituting BC is equal to V and OA is equal to U, we get V is equal to BD plus U or BD is equal to V minus U. From the velocity time graph figure 8.8, the acceleration of the object is given by A is equal to change in velocity upon time taken. BD upon AD is equal to BD upon OC. Substituting OC is equal to T, we get A is equal to BD upon T or BD is equal to AT. Using equation 8.8 and 8.9 we get V is equal to U plus AT. This is the first equation of motion as we have studied this. Now we are going through the second equation of motion, that is position time relation. Thus the distance as travelled by an object is given by S is equal to area OABC, which is trapezium, area of rectangle OADC plus area of triangle ABD. This means that is OA into OC plus half into AD into BD. Substituting OA is equal to U, OC is equal to AD is equal to T and BD is equal to AT, we get S is equal to UT plus half T into AT or S is equal to UT plus half AT square. Here we get our second equation of motion. Now we have studied up to two equation of motion, that is V is equal to U plus AT, S is equal to UT plus half AT square, and this is equation for position velocity relation. Here we are going to basically see the area to find out for a graph for getting a third equation. Here S is equal to area of trapezium OABC is equal to OA plus BC into OC upon 2. Substituting OA is equal to U, BC is equal to V and OC is equal to T, we get S is equal to U plus V upon 2 into T. From the equation velocity time relation we get T is equal to V minus U upon A. Using equation 8.11 8.12 we have S is equal to U V plus U into V minus U upon 2A or 2AS is equal to V square minus U square. We have used here for the simple formula of polynomial, that is A square minus B square is equal to A plus B into A minus B. So here we get our third equation of motion. Our last topic is uniform circular motion. When the velocity of an object changes, we say that object is accelerating. The change in the velocity could be due to the change in the magnitude or direction of the motion or the both. We know that circumference of the circle or the radius r is given by 2 pi r. If an athlete takes t seconds to go around the circular path of radius r, the velocity v is given by v is equal to 2 pi r upon t. Let the following reference image for the athlete along closed track of a different shape in the circular motion. Thank you for attending the lecture and have a great day.